And you gotta break everything apart. Yeah.
It's 2p
So,
equals 2 times 2 is 4 times 2 is 3. 117 times 3 is 9 times 3 is 9.
well,
You need it 17 right? Yeah, 17 And then mine is.
what time is what?
Yeah, it's just
Oh, don't worry, we haven't talked about the ending. So just do the first session. The next 3 are different.
10. I don't know what it's for. So 10,
Yeah.
negative 10.
No.
Yeah. Because minus times.
Sometimes some students like to see this. So if you are one of those people, okay, but that's basically what we're doing. If I have 2 A's and 2 B's, I can put A, B, B minus plus. That's the idea, right? What could A and B be? Anything. So that leads to everything. Let's see, that first problem. Holy crap. Focus. Alright. Nothing comes out of both. There's 2 terms. Because you know what's going to happen on the test, please, right? You know I'm not going to have this section now is squares. No, I'm going to have mixed, everything just mixed. And you got to identify what the hell it is first. Yes, I am. You know I am. Because that's the whole point. Identification is a big part of this. So there's 2 terms. There's no GCF. There's 2 terms. It could only be squares or what we're about to learn, cubes. That's all it could be. So obviously this guy is squares because we're in the squares section. So how do you do this? It's almost too nice to believe, right? Sometimes math is that way. Is everybody? Yes.
So it doesn't matter where the sign goes?
No, this is the same as this. Because that number is the same as turning them around. 6 times 8 is 8 times 6. So this guy, same idea. So what is it? Or the other way around, I don't care. As long as it's minus plus or plus, as long as the signs are different, that's what allows the middle term to cancel.
And we have multiplication between the parentheses.
Beautiful. And multiplication doesn't care what order you put it in. I love it.
I have
Should be.
Is everybody good?
Yeah.
What's up? Sorry. You guys alright?
Yeah.
Are you trying to mess with her? Stop.
Well, why did you switch into the subtraction first? Does it matter?
Oh, I said it could be this way
Oh, okay.
or this way. Okay, here we go. Real quick. Just one time. If I said factor 14 and somebody said 2 times 7 and somebody else said, no man, you're wrong, it's 7 times 2. You're like, so that's exactly what this is saying. It's this. No man, you're wrong. You're both right. It's fine. It doesn't matter what order you put them in when you multiply. This guy's the same way. I just added one extra layer. Good. 4x squared. The 2's and the x's are together. Do you guys see what I mean? They're one term, so they have to stay one term when you break them apart. Sometimes people get confused about where the 2 and the x go. Well, they go together. Because they came together. They're going to leave together. Aww. Doesn't always work out. 25. 5 and 5. Minus plus or plus minus. It doesn't matter. I'm not even going to write it the other way. How are we doing so far? Is it good? Don't let me go too fast. But normally students are like, oh man, why can't all factoring be like this?
Yeah.
That's too bad. Suck it up. That's life. Alright, what about number 4? This one again, it really explains to you why, instead of just jumping into a procedure, always say to yourself, is there a GCF? Right, the first 3, obviously there wasn't any. But here, 8 comes out. Because what is it? Is 8 something squared? So I'm screwed unless I can get it out of the way. Good, so I did. 8, and what's left inside?
X plus 1x.
Well, not yet.
X squared.
And then I can break that up into
8.
Good. I was waiting to see if somebody would tell me. 1 is a little weird because 1 is a square, it's a cube. What's 1 to the billionth power? 1. It's anything you want it to be. It's as many 1s as you want. So it's got 2 1s
You
for
still have
sure.
to simplify that? You can't insert the other one? Or is that fine with the other one?
How do you mean? Sorry.
The first one that you have 8 parentheses x squared minus 1, you still have to simplify that?
Definitely, you have to
Okay.
keep going. So this is just like saying if I factor 18 and you say it's 2 times 9, you're not done because this goes further.
Alright.
So you can take this further. I like it.
36. Right.
How are we doing? There's a random number just out of nowhere. Alright. So you start to realize like number 5 is the same problem as number 3. You guys see what I mean when I say that? Just added another letter on the end, but everything I can cut it in half. So therefore it is a difference of squares. So I can go ahead and do it. Just cut everybody in half. So what do I get?
7m.
7m
Negative 10p.
minus 10p. 7m plus 10p. And I'm done. I like it because there's no 7, 10, MP. They have nothing in common. I like it. And then I throw 6 at you. Yeah, if you thought it was this, somebody wrote that down. How do you convince them very quickly they're wrong? Where's my, you're wrong? Where's it? That won't quite work. How do you convince them they're wrong? Tell them.
We force them.
If you start to mull this out, what do you get? You get 4b, and 4b makes. Is there an 8b in the answer, in the problem? So therefore, that is wrong. That's how you convince somebody that this is wrong. You don't have an 8b in the problem. You can't have an 8b in your answer. So don't write it that. This is what?
Sum of prime.
So it's prime.
Wait.
So again, anything you think it is going to have a middle term. And does the problem have a middle term?
No.
So if I thought it was b plus 8, b plus 2. I get b squared at 16, sure, right? But I also get 8b and 2b is 10b. Do I see a 10b? I must be wrong.
So how do you know that it's fine?
2 reasons. Nothing works, and it's a sum of squares. So a sum of squares is something you identify very quickly as being prime. If it's a sum of squares, it's prime, unless there's a GCF. And what I mean by that is this. Is this a sum of squares? Is that a sum of squares? Yes. But can I factor it somehow? No.
Yes.
Yes, I can. What comes out? 4. Left with what? And that's all. So the only thing you could possibly do to a sum of squares is GCF. GCF works whenever it's there. It doesn't care what form it is. It's like everybody's got a 4. Take it out. But what I'm left with, can I do something with this?
No.
No, it's a sum of squares. Can't do shit with it. Maybe. Yes,
So
ma'am.
even if we identify it as prime and there's a GCF, you want us to factor it?
So if there's a GCF, it's not prime. There's a GCF.
No, okay.
And now in this step, the remainder is prime.
Yeah.
What do you always check
Okay,
first?
that's
What do you always check first? GCF. Does that care how many terms there are? Does it care what form it's in? No, GCF is just always there. If everybody's got something, you can take it out. What's left over is prime.
But we don't write prime right here. That's it.
Now, exactly. You wouldn't write prime because you did take a 4 out.
Yeah.
But the reason you don't do another step is because what's left is prime. Yes, sir.
So why you don't say b plus 2 times b plus 2 is prime?
No. Why don't I say that b squared plus 4 is b plus 2 times b plus 2?
Oh, because it's an 8b. Never mind.
Because when you multiply it out, you do get 4b in the middle, yeah. It's got to be different signs to work. Therefore, since they're different signs, it has to be a minus in the middle.
And because they added to be 0.
Exactly. That's why they have to be different signs.
So if it said B2 minus 16, would it still be prime?
No. If it said b squared minus 16, can I do something with that?
Yes.
Totally.
B squared. I mean,
B
B plus 8.
Chapter 6 is 0.
No, 4.
4.
Wow.
B minus 4.
Okay, I really want this to make sense. They're different signs that allows the middle term to cancel, but since they are different signs, they must multiply to be negative. That's why a difference of squares works and a sum don't work. Some don't work.
Because you can't add a minus to a plus, you can only add a plus to a minus.
I don't, because...
Like on number 2, like on number 2, it's a minus in the equation, and then you put 1 plus 1 minus to make the minus, but if it's a plus, you can't do the same reverse. You can't, like, well, let me add.
Because I need the middle term to cancel. So if this is 6p, I need the other guy to be negative 6p so that they cancel. So I need them to be different signs. Which means the original problem must have a minus sign in it. I really want this to make sense. I need just paper. Just give me some paper. Here was blank space. If I put 2 things in here that have the same sign, are they going to end up having 2 terms? No. So the only way I can have 2 terms is if I make them cancel the middle term out, right? So the only way that I can cancel is if they have different signs. But the minute these 2 have different signs, the last one is going to multiply be negative. That's why difference of squares works, because it allows the numbers to be opposite signs so they can cancel. Sum of squares, they have to be the same sign, they won't cancel. There would be a middle term. Please let that be amazingly awesome. It's so nice. It's got to have no middle term. They got to cancel, so they got to be different signs. So they has to have a minus in the middle. It all kind of leads to each other. It's almost too nice to believe. Math always works like that. It's just not so easy to see that. What about that last dude? The last dude had some of you guys tripping out.
What?
4 minutes.
All right, some order of this, right?
Yeah.
I like it. One of those pieces you can go further with.
The y squared minus 4.
Yeah, the minus, because that's a difference of squares. This guy is done. He just comes for the ride. You write him again. This guy,
Y minus 2.
y minus 2.
Y plus 2.
Now, why did that work? Because I started with 4 y's. How many times can I cut something with 4? I can split them up twice, right? Does that make sense? If I start with a larger power, so I have more of them, I can maybe cut it up in half several times.
What if you have
I don't
like 8?
understand why you did that.
What?
So the real direct reason why I did one more step is because I could. If you can do one more step, you must. Because you're not done factoring unless nothing else goes further. So y squared plus 4, that's one piece of the answer on the second step, right?
Yeah.
But that's a sum of squares. Can't do shit with them. Y squared minus 4, that's a difference of squares. I can factor them. So I got to replace this with what it is. And then I'm done, because these can't go any further, and that's a sum of squares. I know I'm done then. None of the pieces can go any further. So if you think you're done, stop and look at the pieces. Make sure nothing goes further. Okay, I like it. Maybe. It's got to sink in. Oh, good. So we got a little bit of time. Yes?
So, if we were to distribute that out, it would end up like...
Exactly. If you multiply this back out, it's going to come out to be the original. No matter what order you multiply it out in. So that's how to check yourself. Check yourself.
Does that usually happen because there's an exponent on that second y, y2 minus 4? Or is it the combination of that?
It's because it's a minus, and everything can be cut in half.
But can't, on number 2, the p minus 6 be cut down? Or it just has to be in half?
Can you cut p in half? It's a very strange question.
The 6.
So, are you talking about p minus 6?
Yeah.
Alright. 6 can't be cut in half multiplicatively. Don't tell me 3. 9 cut in half is 3 and 3. 6 cut in half is square root of 6, square root of... No, screw that shit.
Okay.
Plus, p. There's only one p. Can you cut that poor little dude in half?
No.
No.
Okay.
So, you had a really good question, though, before I get into the cubes. You ready for this? No, you're not.
feel like you're busting the song.
Are you ready for this? No, you don't want any of that. So somebody just said, what do you add 8 to start with? 11. So let me catch everybody up. 2 terms, no GCF. I can cut everything in half. Right? What's half of x to the 8th? X4 together they make a whole x8. 81? 9 and 9 together they make a whole 81. Plus minus 11.
And we can do more.
X squared.
I didn't. Oh yeah, I had to make it bigger. Oh well, too bad, Joe. X squared.
Minus
3.
minus 3,
If I would have made it so that number would have been a square, I could have gone even one more step, couldn't I? But here we stop because I can't really break 3 up and have it nicely, right? Square root of 3, I don't want to mess with that.
You then have to do the same thing to the left.
This guy?
Yeah.
No, because it's a sum.
Oh, it's an addition.
So it can't possibly work. Yeah, good. The reason this works is the same reason this don't. This minus in the middle lets this work, this plus in the middle don't let it work. I like it. My grammar is amazing. Yes.
What if they have one? Keep going.
Yeah.
Like I said, if that would have been like a 16,
What is
I would have had to keep going.
Yeah.
So the larger this power is, the more steps there might be. All right, guys, last thing. Focus up.
Get it here.
All right. Just to warn you guys, this form of factoring is the one that people hate the most.
Great.
Right? Just in case you already know it and hate it, I'm going to desperately try to make it make sense. Let's do something. Let's say if I had x cubed minus 1, is that a squares?
No.
Obviously not, but it is a cubes. Because x is cubed, and 1 cubed is 1, so 1 is cubed. 1 is anything you want it to be. If I thought the answer was something like this is wrong, by the way. And you can see why somebody might think that, right? You guys see why somebody might think that? You're like, that's a reasonable guess. It's completely wrong, but I agree, it is a reasonable guess. The reason it's wrong, and the reason this is going to be a little bit uglier of a form, is because when I have squares, it's easy. Minus plus, because I got 1 of each thing to make them cancel. Here I got 3 of everything. And I still have to make a lot cancel. So here's what I mean. If you multiply this out, I'm going to do this semi-quickly. So if you just want to watch, it's going to be x squared minus x is minus 2x plus 1. You all can FOIL. I'm not concerned with showing you every step. Are you guys semi? So this will be x cubed minus x squared minus 2x squared is minus 3x squared plus x minus 2x is minus 3x and then minus 1. All right. If you had to, you could do all the steps I just did, right? If you had to. Somewhere in there I made a mistake. Oh, there it is. How many terms does this have? 4. These shouldn't be there. So I have to somehow, squares is hard enough, but we realize it's not that hard. I just have to make one thing cancel. So I just make these two opposites of each other, so it cancels. Here, I've got to make both of those terms cancel at the same time. Oh shit. So I'm just trying to convince you that the process I use can't be quite as simple as the one we use for squares. Because there's more shit to worry about. Are you guys semi with me there? Does that make sense? There's 3 of everything, not just 2. So of course it's going to be a little bit harder. I think you guys are like, just show me what the hell it looks like, man.
So you can't really guarantee which one's going to be positive or negative?
I can. It's all in the process. Okay, here we go. You ready? In fact, let me just, here. Take a second and multiply this out. Multiply that out. Or, several seconds. If you don't do this right, it's not going to quite make as much sense, so be careful. should have cut that.
Yeah.
All right, you ready? This is interesting. If you did this correctly, where do you end up? So if I give you this, that's the answer. Now let's investigate why it makes sense. All right, here. This is kind of weird. I'm kind of trying to develop this a little bit, and I'm going to give you a very straightforward way of looking at it. Just trying to feel out why it makes sense. Do you remember we just did this a second ago, right? Why did I put minus 1, minus 1, minus 1? Because that multiplies to be negative 1. I could have done this instead. Doesn't that still multiply to be negative 1 at the end? So look here. X minus 1, but I've got half of what would normally be there. All right, let me just let that sink in. So what ends up working to make all the coefficients correct so that everything cancels, I really want this to make sense. Let me build this for you. How many x's do I have in the problem?
3.
How many do I have here? 3. So there you go. 3 x's. So I put 1 there, so I must put 2 there so that I have 3 total. Alright? There's a 1, and there's actually, this is like negative 1 squared. You know, that's the other 2 negative 1s there. So if I put 1 there, 2 there, 1 there, 2 there. So overall I get 3. Why were squares easier? Because overall I just need 2. So everywhere I just put 1. That's why it was easy. Here I got 3 of everything. Oh shit. So if I put 1 there, I have to put the other 2 there. So overall I end up with 3 of them. Right? The only thing that doesn't make sense. So if I just start to look at this, this is x times x times x. This is 1 times 1 times 1. So 1x there minus 1, 1 there. So the other 2 x's have to go here. So they get x cubed all together. The other 2 1s have to go here. 1's kind of weird. 1 times 1 is 1. Ooh. The middle dude will always be. Let's do this one, right? If I stop right there, somebody's like, that must be it. Because look, I got my 3 x's and I got my minus 1. What do you want more from me? Well, that's not all I get, is it? What else do I get? I get x and... So if you multiply this out, this is what you get. Do I want this shit in the middle? No. Then I'll watch. I love this. Anybody ever watch Pulp Fiction? No, that's too bad. That one scene where they accidentally shoot the guy in the back, and they have to call the dude. What was he? He was the cleaner. His name was the Wolf, but he was the cleaner, right? He cleaned stuff up. So I need somebody to clean this shit up, get rid of it. That's this dude. So if he's the cleaner, he's got to be the opposite side of this so that he can cancel shit out. And what always works is whatever's here times whatever's here. So it's 1 of each, 2 of each, product in the middle. This is why people hate this, but dear God, if I start with 3 of everything, I put 1 of each here, 2 of each there, and then whatever this is, multiply, put it there. And sure enough, isn't that what we got? Isn't that what that is?
What's plus?
Because this guy, what's his job? To cancel the shit I don't want. Let's make sure he did. What is negative 1 times the new piece?
What?
Negative x. That cancels. What is x times the new piece?
X squared.
Plus x squared. That cancels. So now I would be left with only the parts I want. Let's do another one.
The same thing if it's x squared plus 1 is prime.
No. That'll work. And why? This seems so evil. Can I multiply 3 numbers together and have it come out 3 the same exact number and have it come out negative? Yes. What's negative 2 times negative 2? 4 times another negative 2? Negative 8. So cubes are a lot less uptight than squares. Because I can't square any real number and have it come out negative, can I? But I can cube something and have it come out to be negative, can't I? So sum and difference of cubes, both of them work. And they work the exact same way. Almost. Yes?
So you said multiply for the first term, you start with negative 1 and the x squared to get the x.
So I added this dude in, right? So then I said, what did I just get? Negative x, so that canceled that x out. And I got x times x squared, so that canceled that guy out. Now, right now you guys are worried. You should be, because you're like, what all of all this shit am I going to use when I have a problem? So that's what I want to do. That was all basically me explaining desperately why this process works. Now let me make sure you guys know what the process is. You're like, what part of this was what I have to do? Well, let's do it. Let's do another one. So what if I had y cubed minus 8? Now watch, here's a really big suggestion from me, is break everything down into 3 parts, right? Y cubed is
Y times
y. And what's 8?
2.
Now here's the next piece. I'm always going to have a little dude and a big dude,
Okay.
right? Little dude,
Y negative 2.
big dude. Let me catch up to you. The little dude's a little dude, so you can only put one of everything in. He's a little tiny dude. So I put 1y
Y
minus
2.
1, 2. So where do these 2 y's go?
Here.
So that overall I get y cubed. So as I'm doing it, I'm thinking about when I foil, foil, whatever. I get what I'm supposed to get. That's how I know I'm on track. What are these 2 2's? 4 goes here at the end. So that over, look, I get minus 8. Bam. 1 of each, 2 of each. Why does that make sense? Because I started with 3 of everything, right? Let that make sense. Now how do I get rid of all the other shit that I don't want? What goes in the middle?
Cleaner.
Opposite sign.
What's this times this? 2y, opposite sign.
Opposite.
And that's always positive.
So it's the first 2 terms.
Plus.
Sorry, do it again. Yeah, if I would have had y cubed plus 8, well, let me answer this question. If I had y cubed plus 8, the first term would have been plus, and this guy would have been minus. That's the only difference. That's always the same sign as this, and that has to be different so that it can clean up the shit that I don't want. It's the cancellation term is what it is. So there's a little saying that I used to hate that now I'm using a little bit. I try not to use too many mnemonic stuff because then it takes you away from why it works. But this is the same sign. This is the opposite sign. And this one's always positive, and that spells so. So if you like that, you can use it. Yeah, I know. I prefer you just to know what it does because it makes sense what it does. But you can use that little mnemonic device to remember.
And the square of the sum of cube is same the sum of square, right?
No, I just did one.
No,
I just did it.
I mean, the,
I just did it. I just did it. So cubes can handle difference and stuff. So don't forget what's going on tomorrow, first thing? Quiz. All right.
So, in this one,
Oh, here?
Yeah, because in the last one, you made the one negative.
No, I didn't.
Is this positive one?
Yeah. Why? Because that's the same sign as this, and I made that a minus. Now I would have a positive. That was a minus. I'm supposed to have a
Johnny
minus.
was sick all weekend.
This is always positive because the sign of this is always there. I don't want him to mess that up.
Because if that one was a negative, then
It
the
would mess
answer would
this
be.
up.
alright guys.
If that one was a negative, would it be y3 plus 8?
What's up?
No, there's what y3 plus 8 looks like. Whatever that is, that is. I don't want that to be anything but plus so that it doesn't mess that up. I want positive 8, right? So positive 2 times positive 4 is positive. If I ever put a minus there, it's going to mess that up. Oh, no. The middle term is always these multiplied. So it should be 5x. Well, and it's always the opposite sign. So x times 5 is 5x. But this should be plus, because it's always the same sign as what you had at the beginning. Exactly. And then this should be the other two 5's multiplied, right? So 1 5 is there. 5 times 5, that should be 25. Because right now you get 50, and you want 125. Yeah. But don't worry, we'll obviously do more of this.
So you said the y
Well, I know that this is already going to be the opposite.